Here is to factor the following polynomials. Now, we have a lot of tools in our toolkit of factoring, but I always recommend the first one that you try is see if there's a greatest common factor and then kind of factor whatever's left. So when I look at these two, I can kind of see that there is a greatest common factor of at least 5m. So if I were to pull that out, let's see what's left. If I divided this by 5m, what would be left is 9m squared, and then minus 4. Because again, like if I distributed 5m into here, it would bring me back to where I started. So now when I look at this, I need to try to continue to factor this, and I can kind of see that this is a difference of squares because there's a perfect square here and a perfect square here, and I'm subtracting them. So what that ends up breaking down to, I keep the 5m in my answer, 3m plus 2, 3m minus 2, and if you ever get your answer and you're not sure if that's correct, you can always just multiply it all back together, and it should land you wherever you started. Second one here for B, there's no greatest common factor because it looks like there's, oh, hey, wait, I can combine like terms on this. Is that interesting? So for B here, the first thing I look for is greatest common factor, and it looks like there's nothing here. I'm going to ignore the fact that I could technically combine like terms here, but if there's 4 terms, oftentimes a box can help us. So again, yes, I could put it together and use 3 terms to try and factor it, but I'm going to just try and plug these 4 terms into the 4 boxes here and see if I can figure out what comes on the outside here. So it looks like that, and then it becomes x plus 1 and x plus 7. The reason I didn't multiply or add these two together here is because I'd end up getting x squared plus 8x plus 7, and then I would have to like diamond it, 7x squared, 8x, figure out the two things that multiply to the top, that add to the bottom, and I would end up getting back to the same exact box. So no point necessarily combining like terms on that one. In this case, my final answer is just x plus 1 times x plus 7. For C here, looks like I'm going to have a difference of cubes on this one because I can see perfect cube, perfect cube, perfect cube. So I got to use my kind of formula here where it's a minus b. Here, I'll write it out here. A minus b times a squared plus ab plus b squared. And in this situation, a is 3x because 3x times 3x times 3x is 27x cubed, and b is just going to be 4 because 4 times 4 times 4 is 64. And so now I just plug those in, right? 3x minus 4, and then 3x squared is 9x squared, plus a times b, which would be 12x, plus b squared, which would be 16. And whenever you do a difference of cubes or a sum of cubes, you can't ever factor any more than that. Next one here, I got another, looks like a couple perfect cubes. So this is going to be a sum of cubes, which is a plus b, and then a squared minus ab plus b squared. In this case, a is 5 because 5 times 5 times 5 is 125. B is 2x, so 5 plus 2x. 5 squared minus 10x plus 4x squared. And there's my final answer. And you could put it in standard form, but I'm not too stressed about that. But there's all of our 4 factoring using a couple different methods with our difference of cubes, sum of cubes, difference of squares, greatest common factor, and then the box.